so the next thing we're going to talk about is dilution. So sometimes we might have something that we made too strong. So say for example, I made some Kool-Aid. And this is grape Kool-Aid. Okay? And I made my grape Kool-Aid really, really strong. Like, it's super sugary. You can almost like taste the little grainy particles of my Kool-Aid packet in there. And it's just really strong. And I'm like, whew, that is too strong. So what would you do to make it less strong? You'd add water, right? So if I want this to be less strong, I would add water to it so that I could dilute it so that it wouldn't be as strong. Okay? But then you want to say, well, how much water do I add? In our Kool-Aid example, you would just add some, taste it, add some, taste it, add some, taste it until it tasted right. Then you're like, perfect, I got the right amount of Kool-Aid to water that I want, the right concentration. Well, in chemistry, we can't just sit there and taste it to figure out if we have the right concentration. So what we would have to do is we know how the concentration of the beginning solution, and we know it's too high. So we would need to add water, or whatever my solvent is, add my solvent so that I would lower the concentration to whatever I need it to be. But I have to know what my end goal concentration is. And this is really common. In chemistry, we can buy solutions of all different sorts of concentrations. And so a lot of times you'll buy a solution that's highly concentrated because then you could make all the other ones. You could just add a little bit of water, you could add a lot of water or even more water to get to a different concentration. Instead of having to buy 4 different things, you just buy one and you can make the rest. So it's very common in chemistry to have to do this. Now, if I made something I made it too dilute, how would I go back? Well, you'd end up having to add more solute, okay? But we're just gonna talk about dilution, meaning going this way. Going that way, then you're changing the concentration by just changing the moles of what you have in your solution. All right. So, our solutions are stored as concentrated stop solutions. So usually we have them really strong, that's how we buy them, and then we can make the other ones. So we want to make lower concentrations. So we need to be able to do a dilution. And so there's going to be an equation for my dilution. So let's talk about this. I have a certain volume of this at a certain concentration. So I can call this my 1. My 1 would be that concentration, and I have a certain volume of it, right? So here, certain concentration, certain volume. And what I'm trying to figure out would be, at what volume, how much water do I need to add, what would be my final volume if I want a new concentration? So I need to be able to relate the first concentration in volume to my later concentration and volume. So the first ones are going to be related to the later ones. Okay, so this is my dilution equation right here. So my M is my molarity. My V is my volume. Remember, molarity is in big M units. The volume just has to be the same for the 1 and the 2. Okay? So as long as the volumes are the same for the 1 and 2, they'll cancel out. Alright? And it doesn't matter what you make 1 and 2. Usually 1 is the more concentrated, 2 is the dilute one, what we're trying to get to. Alright, so let's look at an example problem. To what volume should you dilute 0.2 liters of 15 molar NaOH to make 3 molar NaOH? So what am I trying to do? What am I looking for? I'm looking for a volume. Okay, so I'm looking for a volume, and I'm just going to let you know that I want it in liters. I didn't specify that in this problem, but I'm just letting you know. What did they give me? So they gave me 0.2 liters of this guy. Okay, so they told me how much of this guy I have, this molarity of NaOH. And they said that I'm trying to make 3 molar of this guy. So I have this one, and I'm trying to go to this one. All right, so we haven't got here yet, But there's going to be another way that I could go from one thing to something completely different. We already kind of talked about that with stoichiometry, right? We talked about how I could go from one thing to something completely different using a balanced equation in stoichiometry. So what's important with this one is to recognize that I'm going from NaOH just to a different concentration of NaOH, okay? We can only use this dilution equation if I'm going from one thing to the exact same thing. I can't use that equation if I'm changing what my substance is. The other reason I know this is a dilution equation is because it literally says the word dilute. So it says I'm diluting something and I'm going from a 15 molar NaOH to a 3 molar NaOH. So this is dilution. So once I recognize that this is a dilution problem, then I can say, oh, it's dilution. What's that dilution equation Dr. C told me about? M1V1 equals M2V2. That's it. So then I have to figure out, well, what's the ones? So the ones would be the higher concentration. So I had 15 molar, then I'm going to 3 molar. So this would be the 1, this would be the 2, okay? So 15 molar and 3 molar. Those are my concentrations. And then do I know how much of the 15 I have? Yeah, I have 0.2. And then I'm looking for, it said to what volume should you dilute it? So what I'm trying to find out is how much am I going to add, how much should I add to this to figure out how much I would need to fill it up to. So I'm adding water to what volume? So what volume do I need to add water to make my concentration? So this is my question mark. This is what I'm looking for. Okay, so I do the math. So 15 molar times 3 is, 15 molar times 0.2 gives me 3. Okay, and then divide this over and you get that your volume is 1. Now we want to know what the units are. So this is molar and this is molar. So one thing I could have done here, let me change this, is say this is molarity times liters. So big M times L. And so whenever I divide this over, the M's cancel. So I would have left is L. And remember I said whatever volume you use here is the volume you get here, because these volumes are always going to match. So what I would have is I would take this concentration, I would dump it into a flask or graduated cylinder or whatever, and then I would add water until I got up to 1 liter. And once I got to 1 liter, I would know that I'm at a 3 molar concentration. So this would be my dilution, how I make a diluted solution. All right, so the last thing we're going to talk about when we talk about solutions and all this math and conversions is, in this case, I wanted to go from one concentration to another concentration of the same thing. But what if I want to go from one concentration to another concentration of something different? Okay, and that's what I hinted at with stoichiometry. But now we're going to talk about it with solutions, and that's called solution stoichiometry. And that's what we're going to talk about in our next lecture.